Okay, so now we need to talk about how enzymes work. So we classified them, we learned what they are. Well, how do they do work? So, in short answer, they're all different. Every single enzyme has a different shape, has a different structure, works slightly differently. However, there are some general properties in what we're going to learn. So, most enzymes are globular. So, if they're going to do a catalysis reaction, they almost always are globular. Remember, globular meaning that's kind of like a squishy shape. Blob is my favorite word to describe it. And there's very specific 3D folds, very specific secondary and tertiary structure in catalysts or in enzymes. So if we zoom in a little bit on this picture over here, you'll see that our enzyme is the gray part. Gray blob is the enzyme in a very specific form. It doesn't look like it here, but it is in a specific form. Then we have something called an active site, which we'll talk about in a minute. And then just to orient you, the green is going to be our substrate or our reactant. Okay, so the enzyme tertiary folds form a pocket. So that's what I was saying is an active site. So there's typically like a hole in the enzyme somewhere that a substrate molecule can come in. There's a hole or a pocket. This is called the active site because that's where the reaction occurs. An active site is where there's activity, enzyme activity, for our catalysis or for our reaction. Okay, so what happens is that in this pocket that there is, R groups orient substrate and catalyze the reaction. So for example, the substrate could potentially come in any direction, right? Like depending on the shape and everything, could come in any direction. However, particular groups on the substrate interact with particular groups on the enzyme to help make sure it comes in the same way every single time. It's kind of like those people at the airport with the lights saying like, this is where you go. That's what the amino acids in the enzyme are doing. So like, for example, here it shows a hydrogen bonding interaction between two serines, one serine on our substrate, one serine on our enzyme. We could also have salt bridges, hydrophobic pocket, same types of interactions that you'd have in a tertiary structure, and how you have a tertiary fold, but now instead of just to fold the enzyme or fold the protein, it's talking about interactions between substrate and enzyme. So all of those R groups on those amino acids orient the substrate and then also can be responsible for that catalytic reaction to occur. So this tertiary structure is critical to enzyme function for one overall reason, but two specific reasons. It has the shape of the active site. So if you change the tertiary structure of the enzyme, the active site is going to change and therefore have different substrates that bind there. Then even if the active site just gets a little smaller, then the molecule, the substrate molecule, doesn't have enough room to get in. And then it also says what amino acids interact. And so dependent on the tertiary fold, it shows that this, up here, we'll look at it again. It shows that this serine is perfectly aligned to interact with the serine in the substrate. And this salt bridge is perfectly aligned, kind of thing. And so both of these things contribute to the specificity of the enzyme. So because there's a very specific primary, secondary, and tertiary structure of an enzyme, it will have specificity in terms of binding and reaction. Okay, so model for enzymatic activity. We're going to go through this kind of quick because we'll have, in the next video, we'll have more examples of models of this or more specific. But what happens generally is an enzyme and a substrate molecule come together. They form an enzyme substrate complex in purple here. So that's the first step, is they have to come together before the reaction occurs. Then the reaction occurs, you reform your enzyme. So in order for catalysis to occur, In order for catalysis to occur and for it to be actually a catalyst, it must be regenerated after the reaction. And then we also have our product. So it's not enzyme and substrate magically react, right? They come together, form a complex, then the reaction occurs and product is produced and released. Okay, so an example of this would be with sucrase. So let's write out what each of these things are. So enzyme would be sucrase, ASE ending, remember? Then we have our substrate would be sucrose, OSE, because we're talking about the sugar. Then our enzyme substrate complex would be a sucrase, sucrose complex is what we would name it. And then the reaction would occur after complexation, and we would reform sucrase. And in this case, sucrase is a hydrolase, so it's going to hydrolyze and break the bond in between. So if you remember, sucrose is a disaccharide, so it's going to hydrolyze the two sugars. So we'll make glucose and fructose as our two products. Okay, and so in the next video, we're going to talk about models for enzyme activity. So how does this happen? How do we think about this happening?